A computer that plays chess. A vacuum that bumps its way around your living room. A program that writes poetry on request. A car that drives itself through the dark. And a filter, quietly deleting email you'll never miss. We call all of it AI. But those 5 things have almost nothing in common. So, what is AI really? Here's the plan. By the end of this video, you'll have a simple map. Not a definition, a map. And once you have it, every AI headline, every new app, every buzzword you hear over the next 10 years will land somewhere you recognize. You won't have to memorize terminology anymore. You'll just know where it belongs. The problem starts with the name. Artificial intelligence has meant different things for almost 70 years. 20 years ago, turning speech into text was a research breakthrough. Today, it's just a setting on your phone. In 1997, a computer beating the world chess champion made front-page news around the world. Today, it's a free app. Nobody calls it intelligent anymore. Researchers even have an old joke. AI is whatever computers can't do yet. The moment something works reliably, it stops being AI. It becomes software. So asking, is this really AI, turns out to be the wrong question. The better question is, where does it belong? And that's where the map comes in. The map has 3 directions. Let's start with the first. Abilities. Abilities are the big things humans can do that we're trying to teach machines. Seeing, hearing, reading and writing, moving through the world, making decisions. These are broad capabilities. The buzzwords are simply their job titles. Computer vision, that's seeing. Speech recognition, hearing. Natural language processing, reading and writing. Self-driving, moving. Recommendation systems, making decisions. So every AI system begins with one question. Which human ability are we trying to imitate? But abilities are still too broad. Seeing isn't one problem. It's hundreds of different problems. Recognizing your face, finding a tumor in an X-ray, counting cars in a parking lot. Each one is its own task. Even inside the same ability, the difficulty can be completely different. Recognizing one face, mostly solved. Understanding everything happening inside a photograph, the way you can, still incredibly difficult. So now we have 2 directions, an ability and a task. Already the picture is getting clearer, but something important is still missing. Imagine a few engineers. Give them exactly the same task. Build face, unlock. They might build it in completely different ways. One writes thousands of rules by hand. If this, then this. Another counts patterns from millions of examples. A third builds a neural network that slowly teaches itself. Same ability, same task. Completely different methods. That's the 3rd direction on our map. Methods. Not what we're building, but how. And suddenly, the whole picture appears. Every AI system you've ever heard of lives somewhere on this map. One ability, one task, one method. Let's try it. Face unlock. Ability, seeing. Task, recognizing one specific face. Method, a neural network. One square. Now a spam filter. A different ability, reading. A different task, separating junk mail from real mail. And often a completely different method, counting which words appear most often in spam. A different square. Now, your video recommendations. The ability is deciding. The task is predicting what you'll watch next. The method is learning patterns from millions of people. Another square. They're all called AI, but they're scattered across completely different parts of the map. As different from each other as a hammer, a telescope, and a tape measure. The word AI tells you almost nothing. The map tells you everything. And here's the first surprise. Most people imagine AI as one giant brain slowly becoming smarter at everything. But look at the map. There isn't even a square called everything. Real AI systems are specialists. One ability, one task, one method. For decades, that's all they ever were. Now all those buzzwords suddenly have somewhere to live. Machine learning? That's not another kind of AI. It's a method, learning from examples instead of handwritten rules. Natural language processing, not a method at all. It's an ability, reading and writing. Self-driving cars, not one thing. They're dozens of tasks working together, seeing lanes, recognizing signs, predicting traffic, planning routes, steering safely. For the first time, the terminology stops sounding random. Everything has an address. And then something unexpected happened. For decades, different methods won different parts of the map. Some were better for language, some for vision, some for planning. Progress was slow, one square at a time. Then, about 15 years ago, one method started spreading. First vision, then speech, then language, then generation. Cell after cell, capability after capability. Deep learning wasn't solving one new problem. It was becoming good enough to solve many old ones. That's why AI suddenly feels like it's everywhere. The map didn't change. More of it simply started lighting up. And the newest systems don't light up one square at a time anymore. They light up many at once. Nothing has filled the whole map, but something is starting to fill more of it than we've ever seen. Which brings us back to the name itself. Where did artificial intelligence come from? Not from a scientific breakthrough. Not from a great discovery. In the summer of 1955, a young mathematician named John McCarthy was filling out a proposal for a research workshop at Dartmouth College. He needed a title. The popular term at the time was cybernetics, but that word belonged to another scientist, famous and difficult to work with. So McCarthy coined his own. He wrote two new words, artificial intelligence. A name invented for a funding proposal that ended up naming the next 70 years. So the next time a company announces, our product uses AI, you'll hear a different question. Not, is it AI? But, which ability? Which task? Which method? That's the question that actually tells you something. And when tomorrow's headlines announce another breakthrough, you'll know exactly where to place it. One more square, lighting up. One last thing before the lamp goes down. In the beginning, every square on this map was dark. The first serious attempt to light one didn't learn from examples at all. It obeyed rules. Thousands of them, written down by human experts, one interview at a time. For a while, that looked like the future. In a Stanford basement during the 1970s, one of these systems was tested directly against trained doctors. It won. And then it was never used on a single patient. Not once. That's the story of the next episode. A doctor in a box. The rise of expert systems. In the decade AI first kept and then broke its promises. Leave the lamp on.